I'm gonna talk about a question from 2017 comprehensive exam. This is the question. So basically, let's denote F be the larger field. Say F is the field of cardinality Q to the power F. And also say K is the subfield of F such that K has cardinality P to the power E. So K is the subfield of F. So notice that actually we can consider F and K as their additive group. Then both of the additive group of F has the same cardinality of F, and the additive group of K has the same cardinality as K. And by Lagrange theorem, so notice that since K is a subgroup of F, by here we mean the additive group of K and F. Then the cardinality of K divides cardinality of F. So which means P to the power E divides Q to the power F. And since P and Q are both primes, so the only prime power that can divide Q to the power F is the power of Q. So we have P equals Q. So this proved the first result, and then we want to show that E divides F. So now we consider the multiplicative group of F and K. Then the multiplicative group of F contains P to the power F minus 1 elements, because we've already proved that P equals to Q, and other than the 0 element, other elements are all units. So the multiplicative group contains P to the power F minus 1 elements, and the multiplicative group of K contains P to the power E minus 1 elements. So if E divides F, then we are done. So we assume Church's contradiction, assume that E does not divide F. Then we can write F equals to AE plus B for some A and B non-negative integers, and also 0 is greater than B, and B is greater than 0 and strictly less than E, because we already assumed that E does not divide F. Then we can rewrite P to the power F minus 1 equals to P to the power AE plus B minus 1, and equals to P to the power E to the power A times P to the power B minus 1. And actually, because P to the power E is congruent to 1 mod P to the power E minus 1. So our above element, P to the power E to the power A times P to the power B minus 1 is equal to P to the power B minus 1 mod P to the E minus 1. Yeah. And notice that since b is strictly greater than 0, then p to the b minus 1 cannot be 0. And also notice that b is strictly less than e, so p to the power b minus 1 cannot equal to p to the e minus 1. So this means that p to the power b minus 1 is not non-zero mod p to the power e minus 1. And this contradicts the assumption that they are k is a subfield of f, because so notice that since k is a subfield of f, the multiplicative group of k is the subgroup of multiplicative group of f. So actually we should have p to the power e minus 1 divides p to the power f minus 1. Yeah. So this is the assumption that k is a subfield of f. But now we've proved that if e does not divide f, we have e to the power f minus 1 is not congruent to 0 mod p to the power e minus 1, which means that p to the power e minus 1 does not divide p to the power f minus 1. Yeah, and so this is a contradiction. So in conclusion, we have we have p equal to q, and also e divides f.